Good morning. Today's topic is electrolysis of acidified water. Class, why are we saying acidified water? Because water, when it is in pure state, is a non-conductor of electricity. Why is it a non-conductor of electricity? Because pure water do not contain any ions. Since no ions are there in the pure water, therefore the water needs to be acidified with the help of dilute sulfuric acid. So, by adding dilute sulfuric acid to water, the water can be made an electrolyte. So, let us start with the electrolysis of acidified water. So the electrolysis of acidified water must have the electrolytic cell. The electrolytic cell for this we call it as Hofmann's voltameter. We call it as Hofmann's voltameter. The electrolyte that we are using here is acidified water, right? What is acidified water? This is dilute H2SO4 plus water. Then the electrodes that we will be using here are platinum electrodes. What is the specialty of platinum electrodes? That these electrodes are inactive. That means they themselves do not take part in the electrolysis. So electrode में your cathode as well as the anode, they both are both the cathode as well as the anode, they both are to be made up of platinum. Okay. So after that, let us start with the different types of ions that we will be obtaining during the electrolysis of water. So number one after all this is ionization. Ionization of electrolytic water. The ionization will produce obviously the different ions. H2O is going to produce H positive and OH negative ions, right? And H2SO4. Here, H2SO4 will be producing H positive plus SO4 two negative ions, right? So, the total ions that will be present during this electrolysis are going to be the H positive ions. Then we will be having the OH negative ions, and apart from that we will also be having the sulphate ions. We will be having the sulphate ions. So three ions will be there. One is the H positive and two anions, the hydroxyl ion and the sulphate ion. So after this, we begin with the various type of reaction taking place at the cathode and anode. What will happen at the cathode? Now here we have to take into consideration that cathode is made up of platinum, correct? This platinum is an inactive electrode. This is inactive electrode. What is an inactive electrode? The inactive electrode is the one that does not take part in the chemical reaction. So what reaction will happen at cathode? The same principle will be followed. C2C and A to A. That is, the cations will migrate towards the cathode and anions will migrate towards the anode. So first of all, when we are talking of cathode, let us talk of only the H positive ions, because both sulfuric acid as well as the water is releasing the H positive ion. So H positive, right, it will migrate towards the cathode. After migration, it will discharge. How will it discharge? By gaining one electron and will produce one atom of hydrogen. Another cation of hydrogen will undergo the same reaction, plus one electron gives you another H. Alright. Now these two hydrogen atoms, they will combine to produce a hydrogen molecule. It will produce a hydrogen molecule. Why? Because hydrogen is a diatomic gas. Since hydrogen is a diatomic gas, therefore its one molecule will contain two atoms of hydrogen. That is why the two hydrogens will combine to produce one hydrogen molecule at cathode. Now let us see what happens at anode. Now in case of anode, you can see we have got two different anions with us. One is the hydroxyl ion, right? And is the sulphate ion, two anions. So both the anions are definitely going to migrate towards the anode. When both will migrate towards the anode, we know only one will be discharged by which rule? Preferential discharge of ions. Now, what does the preferential discharge of ions say? That out of the two anions that we have got here, the one that will be discharged must be lower in the series of the electrochemical series of anions. And we know that hydroxyl acquires a lower position, whereas sulphate is higher up in the series. So obviously the preference will be given to the hydroxyl ion. So both are migrating, both the hydroxyl as well as the sulphate ion, they both are migrating towards the anode. Only one will be discharged, and which will be that? That will be the one which is lower in the series, so that is going to be a hydroxyl ion. So how does the reaction go? OH negative, obviously the second step is discharge. How will it discharge? By losing. This negative sign means that it is losing one electron and will produce OH. Right? Now this OH is going to combine with other OH plus OH, right? They are going to produce what? They are going to produce, see, they are going to produce H2O plus O, correct? This is just to make you understand that how this oxygen atom is produced by this hydroxyl ion. The same reaction will occur again. Simultaneous reactions are occurring. I am making my point here. Here again another OH negative ion migrate, discharge, produces OH. This OH combines with another OH, correct? Produces another oxygen atom, right? So that means we are getting nascent oxygen atoms. That means oxygen atoms are being produced. Now the same principle here. Since oxygen is also a diatomic gas, so what will happen? O plus O will give us oxygen. Why is it giving us oxygen? Because again, like hydrogen, oxygen is a diatomic gas. So is that clear? How come we are getting the oxygen here? Please keep it in mind that not one hydroxyl ion is getting discharged. All the hydroxyl ions which are present in the water, they will all be discharged simultaneously, and simultaneously this reaction will occur. Now, what is the observation? In the observation we can write that at cathode, hydrogen gas is getting liberated. At anode, the oxygen gas is getting liberated. So as such, there is no observation since hydrogen as well as oxygen, they both are colorless as well as the odorless gases. Hence, we cannot make any observation. So here, in case of observation, what are we going to write? We are going to write the product formed. So the product formed at cathode is hydrogen and at anode it is oxygen. Now here comes another question, that why is that so? During the electrolysis of water, hydrogen and oxygen are produced in a ratio of 1:2. That means 2 atoms of hydrogens are getting produced and only 1 oxygen of atom is getting produced. This is a question that can be asked. How or why the ratio between hydrogen produced and oxygen produced is 2:1? The reason is very simple. See, here for the formation of oxygen, how many electrons are to be released? There will be the release of 4 electrons. How come? Dekhiye. 1 OH negative is releasing number 1 electron. It is giving you OH. So first electron is here. Now here we have written OH plus OH. अब ये OH भी तो कहीं से आया होगा. कैसे आया होगा? By the release of the second electron. Let me just elaborate it. Have a look. We will count on 4 electrons. How are we getting 4 electrons here? So OH negative is giving you OH. Another OH negative is giving you another OH. Okay? Now these both the OH are going to form these two, OH plus OH. They are giving you H2O plus O, the first atom of oxygen. Now here comes the next OH negative. Minus 1 electron will give you OH. Another OH negative, minus 1 electron gives you another OH. Now both the OH will combine to produce H2O plus O. Okay? So now what is happening here is that this oxygen here and this oxygen, they will be producing O2. But during the process, count the electrons that have been produced. Number 1, 2, 3 and 4. That means for the formation of one oxygen molecule, how many electrons were lost? 4 electrons were lost. For the formation of oxygen molecule. How many oxygen molecules? 1. For the formation of one oxygen molecules, 4 electrons were lost. But see what is happening here. In order to form one hydrogen, how many electrons are being used? Only 2 electrons are being used. So what will happen to the other 2 electrons which were produced during the formation of oxygen? So obviously simultaneously these 2 electrons will be used for the formation of first hydrogen atom, and the other 2 electrons simultaneously will be used for the production of the second hydrogen atoms. That is why during the formation, this electrolysis of the acidified water, we get hydrogen and oxygen in a ratio of 2:1. I hope this is clear. Now let us proceed to the electrolysis of aqueous copper sulphate. Alright class, for the electrolysis of aqueous copper sulphate, the electrolyte that we will be using is obviously aqueous copper sulphate, that is copper sulphate salt dissolved in water. The electrolytic cell that we will be using here is either iron crucible or glass voltmeter, right? Either an iron crucible or glass voltmeter. Then the electrodes. Here we are going to use both the cathode as well as the anode copper. Now, this is a special electrode that we are using here, unlike what we had done in the acidified water. There we had used platinum, which was an inert electrode that was non-reactive. But here we are using copper, which is an active electrode. Now, what is this active electrode? The active electrode is the one that takes part in the chemical reaction. Now let us see what are the various ions that are present in this aqueous copper sulphate. So let's have a look. We have dissociation of ions. So what is the dissociation of ions that will be taking place here is CuSO4 will produce Cu positive plus SO4, 2 negative ions, correct? And since it's a aqueous solution, right, it is dissolved in water, so obviously along with CuSO4, water is also present. Obviously they both are going to be producing, they both will be producing the ions. So water will produce H positive plus OH negative. So what total ions do we have here? We have got 4 type of ions here. We have got 2 cations. First is Cu2 positive, the other one is H positive, and the 2 anions positive are sulphate and the hydroxyl ion. So we have got 4 ions, 2 cations, Cu2 positive and H positive, and 2 anions, sulphate and the hydroxyl ion. Now let's have a look that now what will happen at the cathode and anode. Now let us first of all have a look at what happens at the cathode. Cathode reaction will be nothing different from what happens at the electrode when it is inert or when it is passive. जब भी आपका कैथोड पैसिव हो या एक्टिव हो, एज सच उसके रिएक्शन पर इट डज नॉट मेक एनी डिफरेंस, कोई उसमें चेंज नहीं आता, जैसे नॉर्मली रिएक्शन होता है वैसे ही होगा. हाउएवर यहाँ हमें देखना है that we have got two cations, so both will be migrating towards the cathode, C to C. So both the ions are migrating towards the cathode, but both are migrating, but only one will be discharged. And again, according to the preferential discharge, since copper is lower in the electrochemical series, hence the preference is with the copper, not with the hydrogen. Hydrogen is above, copper is lower in the series. So what happens at cathode? The reaction will be Cu2 positive migrates. The second step, discharge. How does it discharge? By gaining. Positive means gain of 2 electrons, and it is going to produce Cu. Till here, not a problem. Now, the difference starts when we talk about the reaction occurring at the anode. The reaction at anode. Now see what happens here. The difference here is, since the electrode that we are using is active, it's an active electrode. What is an active electrode? The one that takes part in the chemical reaction. It is takes part in the reaction. Now, how can an anode take part in a reaction? ये anode is made up of copper. ये ध्यान रखना है. The active electrode that we are using here is made up of copper. So, what will copper do? Rather than allowing any of the anions discharge on it, it will start taking part in the reaction itself. होगा क्या? माइग्रेट तो दोनों एनाइंस करेंगे, सल्फेट भी करेगा और हाइड्रोक्साइड भी करेगा टुवर्ड्स द एनोड, सिंस दे बोथ आर एनाइंस. A to A, anions will move towards the anode. Obviously, they both will migrate. But difference यहाँ आ गया कि यहाँ पर जो हम एनोड यूज कर रहे हैं वो एक्टिव है. अगर ये पैसिव होता, इनर्ट होता, तो ये जो एनायंस मूव किए थे इनमें प्रेफरेंशियल डिस्चार्ज भी होता और उसके बाद डिपोजिशन भी होता. लेकिन यहाँ पर जो हम एनोड यूज कर रहे हैं वो है एक्टिव. एक्टिव मतलब इट विल टेक पार्ट इन द रिएक्शन, तो माइग्रेशन तो होगा. द सल्फेट एंड हाइड्रोक्सिल आयंस विल माइग्रेट, but they will not be able to discharge. Why? Because this anode itself will take part in the reaction. कैसे part take करेगा? The copper itself will start producing its own cations. ये कॉपर अपने खुद के कैटायंस प्रोड्यूस करना शुरू कर देगा. दैट इज हाउ इट विल टेक पार्ट इन द रिएक्शन. दिस कॉपर इज द वन ऑफ विच द एनोड इज मेड अप ऑफ. दिस कॉपर itself will start releasing its own electrons and will start producing the copper cations. These two electrons in the process will be taken over by the copper ions which were present here. यहाँ पर आप एक चीज नोटिस करेंगे कि ये जो कॉपर आयंस है और ये जो कॉपर आयंस है, ये कौन से कॉपर आयंस हैं? Which were present after the dissociation of copper sulphate. ये कॉपर आयंस तो कैथोड के ऊपर माइग्रेट भी करेंगे, डिस्चार्ज भी करेंगे और डिपॉजिट भी करेंगे. लेकिन ये कौन सा कॉपर कैटायंस है? ये वो कॉपर कैटायंस है, ये वो वाले कॉपर कैटायंस है जो हमारे एनोड ने प्रोड्यूस करे हैं. they were obtained from the anode. They have nothing to do with the electrolyte. वो हमारे electrolyte ने produce नहीं करे. ये copper cations produce हुए हैं हमारे anode से जो बना हुआ था copper. Got it? However, they all have the same properties because ultimately they all are Cu2 positive. लेकिन हमारे दिमाग में clear होना चाहिए कि ये copper ions कहाँ से आ रहे हैं और ये copper ions कहाँ से आ रहे हैं. Is that clear? All right. So now let us come to the next step. That is the observation. Now, what is the observation? Observation for cathode. Observation for cathode is copper deposit हुआ था. What is the color of the copper? Either it is reddish brown or we call it as pink also. Pink. A reddish brown or a pink metal deposits. क्योंकि हमें ऑब्जर्वेशन में केवल क्या लिखना है, जो भी चीज हम अपने फिजिकल सेंसेस से परसीव कर पा रहे हैं, that is our observation. So here the copper is giving us reddish brown or pink metal deposition. And what is the observation at anode? The observation at anode will be nil. We will not be able to see anything depositing at anode because the anode itself is producing the ions. Now, after this, one more thing, class. There is a question generally asked: what happens to the color of electrode? What happens to the color of electrolyte? अब यहाँ आपको ध्यान रखना है that aqueous copper sulphate is blue. It is blue in color, right? जो solution आपका बनके तैयार होगा, the color will be blue. This blue color is due to the presence of copper cations. ये कलर है कॉपर कैटायंस का. क्वेश्चन है कि अगर आपका रिएक्शन हो रहा है और कंटिन्यूअसली आपके जो कॉपर कैटायंस हैं वो आपके इलेक्ट्रोलाइट से निकलकर डिस्चार्ज हो रहे हैं और कॉपर की स्टेट में यानी रेडिश ब्राउन और पिंक मेटल की स्टेट में कैथोड के ऊपर डिपॉजिट होते जा रहे हैं, तो व्हाट विल हैपन टू द कलर ऑफ इलेक्ट्रोलाइट? The color of the electrolyte will remain the same. There will be no change in the color of the electrolyte. There will be no change. Why will there be no change? क्योंकि कैथोड पर जो हमारे कॉपर कैटायंस which were responsible for this blue color, ये कॉपर कैटायंस कंटिन्यूअसली जो कैथोड पर डिपॉजिट हो रहे हैं, they are being substituted simultaneously by the copper cations which are being produced by the anode, since the anode is an active electrode. ठीक है, तो कंटिन्यूअसली क्या हो रहा है, ये वाले कॉपर कैटायंस तो डिपॉजिट हो रहे हैं, लेकिन जो ये कॉपर कैटायंस है इनको साइमल्टेनियसली सब्स्टिट्यूट कौन कर रहा है? ये एनोड अपने खुद के कॉपर कैटायंस प्रोड्यूस करके इनका सब्स्टिट्यूट कर रहा है. एक चीज और यहाँ पे आप ध्यान में रखेंगे that the number of copper cations which are discharged at the cathode is always equal to the number of cations which are being produced by the anode. Their number is always going to be equal. Is that clear? The number of these Cations is always going to be equal. जितने भी number of cations यहाँ पर discharge हो रहे हैं, the same number of copper cations are being produced by the anode, and that is why the color of the electrolyte, the blue color, will always remain the same because copper cations posited are equal to the copper cations produced. अब यहाँ पर एक वेरिएशन और करेंगे. Suppose instead of this copper, instead of the copper, अगर हमारा यहाँ पर जो इलेक्ट्रोड था वो इनर्ट होता, एक्टिव की जगह सपोज ये होता इनर्ट. अगर ये इलेक्ट्रोड इनर्ट होता तो इसका मतलब क्या था, ये इलेक्ट्रोड होता इनएक्टिव, राइट. अगर ये इलेक्ट्रोड इनएक्टिव होता तब क्या होता, क्या सेम रिएक्शन होता? इट इज सेम. इन दैट केस हमारे दो एनायंस जो प्रोड्यूस हुए थे, कौन से एनायंस प्रोड्यूस हुए थे हमारे? OH नेगेटिव एंड SO4 नेगेटिव. ये दोनों एनायंस जो प्रोड्यूस हुए थे ऑब्वियसली माइग्रेट करते टुवर्ड्स द एनायन, और माइग्रेट करने के बाद इसके ऊपर डिस्चार्ज कौन सा एनायन होता? वो एनायन होता आउट ऑफ हाइड्रोक्साइड एंड सल्फेट. ऑब्वियसली वो होता हाइड्रोक्साइड आयन. हाइड्रोक्साइड आयन क्यों? बिकॉज इट इज लोअर इन द इलेक्ट्रोकेमिकल सीरीज. और जब ये उसके ऊपर डिस्चार्ज होता तो हमारा रिएक्शन क्या बनता? 4 OH नेगेटिव आयंस minus 4 electrons gives you 2 H2O plus O2. ठीक है. इन दैट केस हमारे पास ऑक्सीजन लिबरेट होती इंस्टेड ऑफ कॉपर कैटायंस. तो आप दोनों का डिफरेंस देखिए. अगर हमारा इलेक्ट्रोड यानी एनोड जो है अगर वो एक्टिव होगा तो हमारा कॉपर कैटायन प्रोड्यूस होगा, लेकिन अगर एनोड हमारा इनएक्टिव होगा, प्लैटिनम का होगा, तो हमारी ऑक्सीजन प्रोड्यूस होगी. हाउएवर कैथोड का रिएक्शन दोनों केसेस में बेशक हम एक्टिव इलेक्ट्रोड यूज करें या पैसिव इलेक्ट्रोड यूज करें, in both the cases the cathode reaction is going to be the same. Now let us come back to this question. What happens to the color of electrolyte? पहले केस में हमने देखा था that it was same. ठीक है. And can you now tell me what will be the answer to the next question if your anode material has been changed to platinum? अगर एनोड इनएक्टिव हो जाए, प्लैटिनम का बन जाए, then what will be the answer to this? क्या यही आंसर रहेगा? No, the answer will change. What will be the answer? Answer will be that yes, it will show change. It will change. और क्या चेंज आएगा? कॉमन सेंस से सोचिए. कॉपर कैटायंस जो ब्लू कलर दे रहे थे, they are getting deposited as cathode after getting discharged. Now they are no more cations. उन पे कोई चार्ज नहीं है जो जिसकी वजह से वो कलर आ रहा था कैटायन की वजह से, राइट. और जो एनोड है वो कोई कॉपर कैटायन प्रोड्यूस ही नहीं कर रहा. तो जो ब्लू कलर था वो जिनकी वजह से, जिन कॉपर कैटायन की वजह से आपको ब्लू कलर मिल रहा था, जब उनका नंबर कम होता जाएगा, what will happen to the color of the electrolyte? It will change. And how will it change? It will simply fade. धीरे धीरे फेड हो जाएगा and ultimately it will disappear. So I hope this is clear to you. Thanks for the day.